Go on, my GCSE science people. Stop scrolling. Because look at the screen. You're looking at a transverse wave and a longitudinal wave. And as you guess, in today's video, we're going to be looking at just a quick revision video for waves, okay? I'm not going to look at everything, but this is mainly for combined science and foundation and higher, but it doesn't really cover a lot of the triple science material. Nonetheless, it's a good video to use to revise and get your flashcards prepared. All right, so on the screen you can see that there are two waves being shown. You're seeing a transverse wave and you're seeing a longitudinal wave, okay? You're seeing two slinkies. So as you can see, the vibration is going up and down, but the wave is moving perpendicular. And in this example, longitudinal wave, the vibration is going back and forward and the wave is going in the same direction, okay? So that's a good way to just remember the difference between a longitudinal wave and a transverse wave. But by definition, you need to know that a transverse wave, the vibrations, or your textbook would use the word oscillations, are perpendicular to the direction of energy transfer. Okay, here are some examples of some transverse wave. Your S waves, all right, your triple science students would definitely know what I'm talking about there, which is a type of earthquake. Gamma rays, X-rays, UV, so anything that has to do with the electromagnetic waves, those are examples of transverse wave. Light waves are also an example. Okay, so you can just use the letter T, all right, to know that that is perpendicular. That can be used to remember that transverse wave, it is perpendicular there. Okay, good. All right, so transverse waves can be represented by that graph shown there. A longitudinal wave, the vibrations are parallel. So you can just use the two L's to remember that the vibrations are parallel to the direction of energy transfer. All right, here are some examples: sound wave, ultrasound, P waves. Those are examples of longitudinal wave. Whereas for transverse, you know that light is one such example. Anything that has to do with your electromagnetic waves. Okay, good. So now that we know the difference, please ensure that you can label the different parts of the wave. So have a look at this, add this to your flashcard, make sure that you can label the different parts of your waves, okay? All right, so I reveal the answer now. Okay, so you have your wavelength, okay, you have your trough, you have your peak, you have your amplitude. All right, so let's say that is my rest position. My amplitude is there. Make sure you know the definitions for the different parts. So your wavelength is the distance between two successive points. For example, a peak to a peak. So that's a wavelength. Another successive point, all right, from that point to that point, or you can have from a trough to a trough. Okay, so it's not only a peak to a peak. Your amplitude is the maximum displacement of a point on a wave away from the undisturbed position. So if that's my zero line, it's from the middle of the wave to the top of the wave. Okay, and frequency is the number of waves that passes a point every second. Please also add this equation to your flashcards. Okay, V is equal to F lambda. Okay, good. Well, the thing is, you're going to have their equation sheet this year, so you don't necessarily have to remember it, but you do need to know how to use that equation and make sure that you know your units and know how to rearrange. Okay, good. And the time period in terms of a definition is the time taken for one wave. T is equal to 1 over F. Okay, flashcards should be fully populated. Too easy. All right, let's go. Now, this is one of your required practicals that you need to know. All right, the Ripper tank. If you're not sure about the Ripper tank, I have a video. Just go through my TikTok page. You can notice, you can go through that video where I go a bit more in depth. This one is just a quick revision. All right, so have a look at the main points here that you need to know for the Ripper tank. Okay, you're going to be measuring the number of waves here. You can take a photo and you can include that ruler in the photo to measure the distance between the wave. All right, that would give you the wavelength. In order to measure the frequency, you could also take a video and count the number of waves that is passing a given point. Let's say 10 seconds. all right, and you measure that time, and then you can use the formula v is equal to f lambda to work out the speed of that wave. I go more in depth with a next video. Just go through my TikTok page, you'll find that. Okay, another core practical which you need to know, a required practical, is the waves on a string. Okay, so what's happening here is that you have a vibration generator which will give you some sort of frequency. This wave is going to go up and down on the string. You can measure, use a meter ruler to measure how many half wavelengths you can get, and then you divide that length by the number of half waves. Okay, I'm going to definitely do a next video on that, and then you use that formula v is equal to f lambda. Make sure you know that required practical. Now, electromagnetic waves, okay, what you need to know for electromagnetic waves is that they're all examples of transverse wave that transfer energy from the source of the wave to an absorber. Okay, it's a continuous spectrum, and you need to be able to talk about this spectrum and know the spectrum in this order. Okay, now I have something to help you to remember it, so you can use Rode man inflicts violence upon ex girlfriend. Okay, and once you know that, you're going from long wavelength to short wavelength. Okay, and if the wavelength is long, it means that the frequency is small. Okay, so you're going from a small frequency to a higher frequency. Okay, good. Make sure you add that to your flashcards as well. All right, another experiment, another practical that you need to have an idea of is this practical here, in which you have an infrared detector, and what happened in your Leslie cube, you're going to be having some hot water inside. Okay, and you have your infrared detector, so it goes around and it measures the amount of infrared radiation which is coming off. Okay, so which surface will be the hottest? Your matte black will be the hottest based on the infrared here, because it's the best emitter. Your matte black would also be your best absorber and your worst reflector. Okay, good. And the shiny surface, so your shiny surface right there, it is going to be the worst absorber and the best reflector. Obviously, you're going to keep the distance of the infrared detector the same as you go around each point. All right, and what you're changing the different surfaces. Okay, good. Now, there are lots of uses about electromagnetic radiation which you need to know. I mean, that is very complex. All right, so here is a summary. So radio waves, all right, get your flashcards ready, make sure you put that on. It's used for television and radio, microwaves, satellite communication, infrared, your heaters, visible light, we use that for fiber optic communication, and then your UV is used for lots of different things, sun tanning, your x-rays and gamma rays, that's used for medical imaging and treatment. Now we're going to be looking at some questions based on waves. Okay, and let's get this started quickly. All right, so for waves, there's several uses for UV radiation, lots of them that you can use. Okay, what we're going to go with is that we can use UV to suntan. Okay, I like that one. Okay, especially living in the UK, lots of people use UV radiation for sun tanning. You could also go with other examples such as energy efficient bulbs, sorry about my handwriting. You could use it to sterilize medical equipment. There's lots that you can do. Anyways, let's move on. A UV wave has a wavelength of 300 nanometers. Okay, make sure that you know your units. So nano, okay, 300. The prefix nano means 10 to the minus 9. Okay, so what happens is that, look at the answers provided here with you. So there are two zeros that you're going to be multiplying. If you put that on your scientific calculator, or if you're very good with math, you know that you're going to be reducing that by 2. Okay, so it's going to be 3 times 10 to the minus 7. So our answer is going to be here. All right, next question says that the speed of UV waves is 3 times 10 to the 8. Calculate the frequency of the UV wave. Use your answer that you've given here. So even if you're given the wrong answer here, there's something called ECF, error carry forward. You will still get the mark if you've done this correctly. Okay, so what we should know here, we know that the speed of a wave v is equal to f lambda. Okay, so they now want us to work out the frequency. So frequency is equal to v divided by lambda. Okay, if you're unsure, make sure you go with your magic triangle, v, f, and lambda. Okay, so if you require f, f is equal to v divided by t. Okay, that is if you're really not good at transposing. Next thing that we need to do now is to plug our values in. So we have 3.0 times 10 to the 8. That's all going to be divided by your answer, which is given here, which is 3.0 times 10 to the minus 7. Okay, and if you've done that correctly, your answer, your frequency should be equal to 1 times 10 raised to the 15 hertz. Okay, good. And that's going to give you your 3 marks. Okay, all right, let's move on. So with this question now, it gives you the table below gives the wavelength of a UV wave and 3 other electromagnetic waves. Okay, so what they want us to do now is to match what's going on. 1 mark, but just remember, roadman inflicts violence, right, upon ex-girlfriend. Okay, you have lots of other ways you can remember that. Okay, so remember, this is going from, in that example, this is going from the longest wavelength to your shortest wavelength. So you're right here. So it's going from your longest wavelength, UV. Okay, it's going from, so what's happening here? You're going from your longest wavelength to your shortest wavelength. So what's happening here? Your wavelength is small, then bigger, then biggest. Okay, good. So our answer has to be, so wave E, which is your smallest, X-rays is your smallest one. So wave E, which is your smallest wavelength, that has to be your X-rays. Good. Then F, which is the medium one, that has to be your visible light. Okay. And then G has to be your infrared, which is going to be the biggest one there. So this one has the longest wavelength of the 3 examples here. Okay, good. All right, so once you've done that, you should be getting that correct. Lots to think about for 1 mark there, but that's fine. Next example here, describe the difference between longitudinal and transverse waves. So just remember, for transverse, just remember that your T in transverse, that means that it is perpendicular. So transverse waves, vibrations are perpendicular to energy transfer. Okay, too easy. All right, to energy transfer. Whereas with longitudinal, all right, just remember the 2 L's. All right, means that the vibrations, longitudinal vibrations are parallel to energy transfer. Don't mind my writing. Okay, good. Now here's another example, all right, of a wave question. So in this question here, the question is asking us, what is the advantage of repeating the measurements and calculating the mean? So the advantage of repeating is so that you want to reduce random errors, okay? So to reduce the effect of random errors, okay? Do not write that you are trying to anything about anomalous results or to improve accuracy. Students like to talk about accuracy. Do not mention anything about accuracy there. Okay, so the teacher's measurements for the time taken for 10 waves to pass the mark were 8.4, 7.8, 8.1. Calculate the mean frequency of the wave here. Okay, 5 marks. Now this is not difficult. First thing, let's find, there are different ways you can approach this question, but let's find the mean of the time here. So how would we find the mean? It's going to be 8.4 plus 7.8 plus 8.1. All of that is going to be divided by 3, and that's going to give us an answer of 8.1 seconds. Okay, now it says that's the time taken for 10 waves, so we need to now find the time taken for one wave. Okay, so what we would need to do is 8.1 divided by 10, which is going to be equal to 0.81 seconds. This is the time for one wave. Okay, because if 10 waves took that time, to find the time taken for one wave, you'd have to divide that by 10. Okay, and then to find the frequency is equal to 1 over the wavelength. Okay, this is going to be 1 divided by 0.81. Okay, and if you done that in your calculator, you're going to get a frequency of 1.2345, lots of other numbers. But the question tells us, and do not lose those marks, once you've used all the numbers in the question, even if you didn't get it right, you just try to get that mark about significant figures. So rounding that to the correct number of significant figures, that's going to be 1.2 hertz. Okay, all right, so let me know what else on waves that you would like me to go through. All right, triple science, I know you want me to go through light, refraction. I've been getting lots of questions about that. And just remember, it's only GCSE science, not rocket science. I'm out.